File descriptors in C are a very thin wrapper over what POSIX provides. The file descriptor table is hidden from programmers. A file descriptor can represent a file on disk, a virtual file such as a pipe, a network connection, or any other file-like thing. The unistandard.h and fcontrol.h header files provide many function prototypes that work with file descriptors. C provides constants for the standard in, standard out, and standard error file descriptors. These are set to 0, 1, and 2 respectively. There are also variables called standard in, standard out, and standard error. Use the file noconstants or the variables depending on the function. The open function takes a path to a file and returns the file descriptor. A file can be opened for a few modes. The most common ones are read-only, write-only, and read-write. If open fails, it returns -1 and sets the global error no variable. There are many possible error codes. For example, the user may lack the permissions to open the file in the desired mode, the file may not exist, or the process could have no more room in the file descriptor table. Create a new project. Make the source and include directories. Move main.c to the source directory. Reload the cmakelists.txt file. Make sure that the file name is passed on the command line. fprintf works the same as printf, except that you can specify the file to print to. Error messages should be printed to standard error. Compile the code and fix any warnings or errors. Run the code without arguments to ensure that it prints the message and exits. Open the file for reading. There are many ways to handle errors. You must check the return value of the functions to see if an error occurred. The stir error function takes the error no and returns an operating system specific error message. Exiting a program when an error occurs is not necessarily a good idea, but it can be done for a simple test program like this one. Compile the code and fix any warnings or errors. Adding no-lint comments is annoying, but the alternatives are to turn off the warnings or ignore the warnings. Ignoring the warnings by not fixing them is a bad idea because it will make finding other warnings harder. Turning off warnings could be okay, but these ones are important for more advanced programming. Do not simply add a no-lint comment to silence a warning. Understanding when it's safe to ignore a particular warning is crucial. When a file is no longer needed, be sure to close it. If you fail to close a file, it will continue to hold an entry in the file descriptor table. If the file descriptor table for a process runs out of room, it cannot open any more files. You could run the program by editing the configuration, but opening it in a terminal will be easier. Run the program with a file name where the file exists and one that does not. The program should give an error message for the file that does not exist. You could make a new project to test creating a file. However, that will mean creating a lot of little projects as we go on. Instead, create a function for open and another one for create. Highlight the code for open, right mouse click, and select Refactor Extract Method. There's no need to pass in the FD result variables. Call the function doOpen. Move the FD result variables into the doOpen function. Copy the function and call it doCreate. Make them static. To create a new file, call open with the ocreat flag. You can also use the creat function to create a file. Notice that for historical reasons, the name is creat, not create. The open function provides more flexibility than creat. When creating a file, the mode controls the permissions for the file. Modes can be ORed together to control the user, group, and other permissions. The OEXCL flag causes open to fail if the file already exists. It doesn't give an error when we go and create a file that already exists. Why not? I modified the wrong function, an easy mistake to make. This is why it's important to test frequently. Modify your code and then test the modification as soon as you can. If the modified code does not work as you intended, then the problem must be with the changes you just made. If you've not made many changes to the code, it should be easy to find the mistake. The doOpen and doCreate functions look very similar. Most of their common code has to do with error handling. When you see common code, it's a good idea to make it a function. Make a new file, fileutils.c, and the associated header file. Move the header file to the include directory. Add the new files to the cmakelist.txt and reload it. Make functions for doOpen, doCreate, and doClose. Move the code from main.c to the file utils.c file. This practice is called writing wrapper functions. A wrapper function enhances an existing function. For example, open is enhanced with error checking. There are now two functions called doOpen and two functions called doCreate. Rename the functions in main.c to start with test instead of do. A wrapper function typically has the same parameters and return type as the original function. Now the test open and test create functions are much easier to read. A wrapper usually doesn't hard code anything. The point is to use the wrapper function the same way as the original function. Printing a message followed by exit is not a great way to handle errors. However, it's perfectly fine for test programs such as this. Compile the program and fix any warnings or errors. Test the program. Remove the generated files. Test the program again. There's an error creating the file. I forgot to pass the ocreat flag, so the file was not created. The file was opened instead. Test the program again. When making changes, always test them. You never know what mistakes you could make. The write function returns size t, which stands for signed size t. This means it can return -1 for an error, or a value up to size max for success. This is probably where your eyes start to glaze over. Types in C and POSIX are interesting. If there wasn't an error, write returns a number of bytes successfully written. A file must be opened as write-only or read-write for the write function to succeed. The write function can fail for many reasons. Use the write function to send data to a file. The write function takes a pointer to a memory area and the number of bytes to write from that area. Write takes a file descriptor, not a file. This is a deliberate choice. In POSIX, everything is a file, or, more accurately, everything has a file descriptor. Everything does not literally mean everything. However, if something can be viewed as a file, it is. This means that the write function works with anything represented by a file descriptor, such as a file. The test write function can use the file created by the test create function. Test the program. Don't forget to add the new line. Appending to a file means that new data will be written to the end of the existing file. The read function is the exact opposite of the write function. Reading from a file requires that it be opened in O read-only or O read-write. Read will take data from a file and store it into an area of memory. The number of bytes to read must be passed in. Make test functions to read a string and a char. Reading a string takes an array. Remember that the array's name is the same as the address of the first element of the array. Reading a char takes the address of the variable. The memset function sets the memory for the array to a specific value, in this case the null byte. This ensures that if less than 5 bytes are read, the string will end with a null byte. Run the program. Change the settings to pass in the arguments. The file can't be found. Every process has a current working directory. The current working directory is where the process was started from. All files are opened or created relative to the current working directory. clan starts the process in the cmake build debug directory. Set the directory to be the project directory. CLion does not expand the tilde. Put in the absolute path of the project directory. Now it runs, but there's an error. There are also a lot of compiler warnings. Rather than try to work out what's wrong, fix the warnings. There's a good chance that the bug will be found in one of the warnings. memset is a useful function, and the C11 functions are optional and not well supported, so you should avoid them. Size of is preferred to hard-coding a number. Remember that size of array can only be used in a function that knows the size of the array. Otherwise, you will get back the size of a pointer to the first element. The code compiles cleanly, but the error is still there. Having clean code does not guarantee that your code will work. You cannot read from a file that is opened only for writing. Pay attention to the mode you use when opening a file. If you only want to read, use read only. If you only want to write, use write only. If you want to read and write, use read write. Do not be lazy and use read write for everything. If you accidentally write to a file you meant to be read-only, it can be challenging to track down. File modes are very similar to const. Use const if you do not want a function to change the variable contents. Use read-only if you do not want a program to change the file contents. This is part of what is known as defensive coding, which reduces the number of bugs substantially. Now the code works. Sometimes you may need to jump around in a file. Depending on the type of file, remember everything is a file, it may be possible to change the current offset. Every file has a current offset, which is a number of bytes past the start of the file. The read operation reads starting from the offset, advancing the current offset as it reads. The write operation writes to the current offset, advancing the current offset as it writes. The lseek function can seek a position in the file based on the start, the end, or the current offset of the file. The lseek function takes the file descriptor to work with, the number of bytes to move, and the type of seek to perform, start, end, or current. The return is an oft, which stands for offset. Oft is assigned integer value. Unix was created back when memory and hard drives were much smaller than they are today. Historically, C has heavily used the int type because it is the fastest data type. Now computers are faster, and they can read and write huge files. The length of a file can exceed what oft provides. POSIX makes writing portable C code easier, However, POSIX does not provide for every possible abstraction, and you may need to resort to operating system-specific code. If you need to deal with files larger than 32 bits, or about 2 gigabytes, then you will need to resort to using system-specific functionality for now. A later release of C or POSIX may add support for larger files. Create a test function for lseek. Open the file for read-write. Seek into the file. Write ABC to the file. Call the test file with the file containing Hello World. Seek to the end of the file. Actually, make the function more flexible and pass in the data to write. Calling strlen in the write function call is a bad practice. It makes the code harder to debug, and if you need to use the value of strlen in 2 or more places, it is better to store it in a variable rather than recalculate it each time. Move strlen after the call to lseek has succeeded. If open or lseek fail, then there was no point in spending time calculating the length of the string. These sorts of easy-to-do code optimizations can significantly impact the speed of the code. Don't focus on the speed of the code to start with, but don't go out of your way to write slow code. Make sure the code compiles cleanly, with no warnings or errors. Run the program. Open the text file. ABC appears at the end of the file, as expected. Rerun the program. The file was open in append mode, so the offset was already at the end of the file. Seek to the start of the file and write XYZ. The start of the file was overwritten with the new data. Use the ftruncate function to reduce the size of a file. At this point, the code is basically the same as the other parts. Create the wrapper prototype. Create the wrapper function. Create the test function. Make sure the code compiles cleanly. Test that the code does what it should. In this case, the file size is reduced to 5 bytes in length, as requested. The dupe function makes a duplicate copy of an existing file descriptor. The file descriptor table looks a bit more complicated now. It has been split into 2 parts. The file descriptor table now contains pointers to a second table, the file table. The file table contains the actual information about each file. This allows multiple file descriptors to point at the same file entry. Use the dupe function to get a file descriptor that points to an existing file entry. Once a file descriptor is duplicated, you can read from or write to either one with the same effect. The code is straightforward. The fcontrol function is more versatile than dupe, but, for now, it can be ignored. Writing to the standard out file now, or the file descriptor that was passed in, will print to the screen. Changing to the duplicate file descriptor also writes to the screen, as expected. The dup2 function causes an existing file descriptor to point to a different file table entry. For example, if standard out file now is passed to dup2, it will change to point to the requested file. Now anything written to the standard out file descriptor goes to the file instead of the screen. Write the wrapper and test functions. Pass in a file name to create for the dup2 test. The program does not work. Create the file instead of opening it. Why does creating a file require ocreat? That should be part of the doCreate function. Now there are warnings. Remember that you should only OR unsigned integers. Just because of how C works, you need to jump through some hoops to get this to compile cleanly. Now writing to standard out writes to the file instead. You have implemented the same sort of I/O redirection that the shell uses.